speaker will be Anne-Marie Walters, Bentley Systems Global Marketing Director since 2004. She is responsible for the marketing solutions and products. MS Walters, a chartered chemical engineer, represents Bentley on the board of the Construction Industry Institute and is involved in the activities of FIATEC. She was on the board of the Engineering Contractors and Constructors Association 2005 to 2010 and was the chair in 2009. She is also a founding member of the Process Industries STEP Consortium, PISTEP Committee, and has served on the boards of CIM Steel and the United Kingdom's chapter of the International Alliance for Interoperability. Please welcome Anne on stage.
I'm going to give you a live demonstration, so I'm just getting my PC set up, so just give me 2 minutes, or 1 minute, to start my presentation up here. Thank you very much for having me again. This is about my 3rd year I've presented to you here, and this year I'm going to really be talking about how Bentley and our customers have gone digital, and a couple of I always try to bring you up to speed on where technology's at and where we're at nowadays with what we've been doing. So basically, the presentation that I'm going to give started off with being what our CEO presented back in February, but things have changed so rapidly also in the 6 months, or in the 4 months that this presentation was given. I've actually added a whole pile of new stuff that we presented at the Hanover Fair in April as well. So we've talked a lot, you've seen the convergence of the IT and OT, we've talked a lot about that. This is what the focus of the conference here is about. But you'll notice here that we have a gap, and we'll always maintain, Bentley's a software company, we specialise in engineering software, and we believe that the IT-OT gap is bridged with engineering technology. What do we mean by engineering technology? It's things like all the analytical models that you've used to... Do you want me up? Okay. Is that better? Okay. It's all the analytical models that your engineers will be using to test whether your facilities are going to stand up in the wind and seismic and pipe stress and high pressure piping and that kind of thing. Schematics, your P&IDs that you use to drive your process plants all the time, the logic of how things are connected together. Sometimes you've got design models. You've certainly got, most of the time you've got design models during during a project phase, but now bringing those design models into operations and maintenance for use for operator simulation and that sort of thing. So that's the design models you've got. Sometimes you have construction models as well, how the thing was actually built. You've also got a lot of information, a lot of engineering information from your supply chain about how your equipment is designed to work and how it actually works. And then you probably also have a lot of network models, geographically where things are placed, logically how things are connected together. All of this information it can be summed up as digital engineering data, which is extremely valuable when you're trying to assess, make decisions about how to improve your assets or how they're performing, and go forward. So we also talk about the digital engineering model gives you the baseline of what's there, what it's designed to do, what it was meant to do, and so on. It also, therefore, then how it's actually performing gives you your frame of reference. And then, because you know how much, you know what it's supposed to do and what it was meant to do in the first place, it also gives you that digital DNA, that what it potentially could do for you in the future and going forward. So we reckon engineering technology is that bridge between IT and OT, giving you valuable information on which to be able to make decisions. From a going digital point of view, what you need for digital engineering models is a comprehensive modelling environment that totally covers everything you need. And we talk about industrializing BIM. This is your project side. This is the repeatable engineering that you can do. This is the modularization and being able to sum up what a potential asset, the description of a particular asset in terms of a modelling environment. You also need a fairly comprehensive performance environment. We've seen a lot about the sensor technology and the monitoring and the monitoring of these assets, but also its failure modes. How could it possibly go wrong? This is what we call a comprehensive performance environment, and having that information helps you leverage the digital DNA. And then you definitely need all this data connected together. So we believe in a connected data environment, and our project world connected with our operations world share common data, basically, and share common data openly with other systems as well. Interoperability is a big key thing for Bentley and also for making all of this work together. So just very quickly then, for those of you who don't know Bentley, and we are a total software company, we focus on advancing infrastructure. We provide modelling applications for all of these areas, so mining, cities, utilities, buildings, that sort of thing. Microstations are core modelling environment. You may recognise some of the names. I've just homed in on process industry. Some of the names of the engineering applications here. I'm sure many of you use these engineering applications. We have a connected project environment for collaborating across projects called ProjectWise. You'll note Azure, if you can see it. It's all based on the Azure cloud, which we have in common with a lot of companies, most secure environment for sharing information over the cloud. We also have an operations and maintenance environment called AssetWise. We made a number of acquisitions over the past few years, and now we have reliability-centered maintenance applications, operational analytics applications, all of that sort of thing, all summed up in an asset lifecycle information management as well, all summed up under the AssetWise portfolio. That's also on Azure, and they share both the projects and the operations environment share a common connected data environment. So that's us. From an ARC point of view, we are number 2 overall in the engineering design tools. Our revenues are split between two main market surveys. We're number 2 in the engineering design tools for plants and infrastructures according to ARC, with number 1 in these couple of areas, and that's according right now up to date as well, even for August 2017, although it's not quite been released yet, but free information there. And then we're also covered in the Asset Reliability Software and Services report as well. And that'll be out shortly. I've just provided the numbers to ARC for those, and we're going to actually be number 1 in a lot more industries for this, because this is the area where we've grown most significantly over the past couple of years. So we're both projects and operations, I always say. I'm now going to give you a couple of examples as this video goes through. This is a particular client, a refinery client, which I'm not allowed to name, but they are leveraging their digital engineering models. They ask for 3D plant design models back from their contractors, and then they're using these 3D plant design models to provide their operators in the operations and control room, in their operations centres with live data in terms of how particular assets are performing. So what you can see here is a combination of the 3D modelling world with our operational analytics tools to literally give the operators a live environment there. And then it's also got the information down the side here in terms of what's actually happening. They can click in and go, that the operators can learn more about their operations and really track it. And I think the speaker from Reliance said, being able to bring your operators up to speed more quickly and provide them with better information so that they can manage and operate the plants more safely and so on and so forth is pretty key. And we're seeing a growing adoption of 3D modelling to provide that a picture says 1,000 words, rather than having a dashboard, having a picture like this. It says gets across the information much more readily to those operators. And we're here with the combination of operational or Internet of Things operational information straight onto the 3D model is what they're using in their control rooms. Another example and this is an example of business transformation. It was a winner of our year in infrastructure, year in infrastructure competition last year, and we actually have a whole pile of these examples. In each year we ask our best users to submit their most globally impressive projects, if you like, and then we sum it up into this yearbook, and we've got a few copies of that if you want to have a look and explore some more examples. But this one in particular is a business transformation example. They won the Innovation in Asset Performance last year. Danfoss, their name is. They make refrigerators for big retail customers. They basically provide the freezers for grocery stores all over the world. And that's what they do as a business. They make refrigerators, but they've transformed their business now into being energy managers for the retail industry. And instead of just providing refrigerators, they also manage, control, maintain all of these refrigerators. So they were actually a presenter at the ARC Forum in Orlando, and there's a video of their presentation as well. But basically, they're tracking things like temperature, humidity, whether the compressors are on and off, the set point of compressors, and then they're managing for every store in which they're, and there's something like 5,000 stores globally that they are providing the energy analysis for. Basically, they are managing how the compressors should go on and off, how to balance the use of those refrigerators all across their customer base, and they're able to optimize the amount of energy usage, reduce the customers, their retail clients' use of energy, but also, like I say, they're not actually selling or providing refrigerators to the clients. They're actually managing their energy usage and being paid on the basis of energy usage rather than refrigeration hours or refrigerators. So they're also able to they've also used machine learning particularly to really predict how the refrigerators are performing and be able to optimize and track those ones that are beginning to fail, swap them out quickly, that kind of thing. So it's all ways to optimize the energy usage. And for supermarket chains, the being able to cut down on the amount of energy they're using is a huge return on investment to their bottom line. So this is a really good example, and I encourage you to look up the presentation that Rick gave at the ARC Forum in Orlando on that one. So basically, just coming back here, providing digital engineering models bridges that gap between engineering, between information technology and operation technology. But what if you actually don't have an engineering model? And I spoke last year a little bit about our reality modeling technology, and I'm just getting to this because this area has just skyrocketed in terms of usage. Basically, reality modeling is the taking of photographs or picking up of information of your existing assets and then turning them into a 3D model. So I showed this last year. This is our classic kind of view. Basically, this is a model of a substation with which comprises aerial photography plus images up front, so that you can get right down to the detail. So you can see here the condition of the assets. You can even, with close range photography, really get into it right close up. And I'm going to come back to this in a moment. But basically, that gives you a quick view of reality modeling. And this technology has now been around for about 3 years, basically. One of the things that our CEO introduced back in December at a conference was a new word, inspectioneering, basically, which is the combination of inspections with engineering. So inspectioneering. So I'll give you an example of what that actually is. So take that same substation that we've got that we create. We captured the reality model here. Here you've got the engineer zooming in on that nameplate for that particular compressor, being able to scan the photograph. It's highly detailed photography here. Being able to scan that photograph and identify the asset, and from that, the identification of that nameplate, be able to identify that asset and pick up all the other information that he knows about that substation. So from his desk, rather than going out to the site and having a look at this substation, seeing where it is, simply from picking up the reality model and the photographs, he's able to really work out all the information about where that asset is, how easy it's going to be to get to, he's basically been able to do the inspection job from his desk. So that's what we mean by inspectioneering. Here's another example of a bridge inspection. You could see the guy there taking a few photographs of this little crack in a bridge. Basically, the guy out in the highway is he's taken about 12, 14 photographs. Basically, you wonder what you can actually get from such a model. But here you go, the engineer, he's able to share the 3D model with the engineer back in his desk. Here the engineer can go right in on that crack, have a look at it now and start to look at the kind of depth. How deep is that crack really? If you look there, you can actually measure, for example, the depth of the crack. And now he's superimposed, because he knows there's rebar in this bridge, just to work out how serious is this crack. Is this crack just something simply, as it shows here, a fault along the rebar? So actually the bridge itself is still integrally okay, basically. Right. Drone acquisition and putting digital cameras on drones and sending them up, things like control towers are also taking off. We did a survey of the oil and gas industry to find out how many people are using drones for inspections these days. It's 1 in 3 of all offshore platforms now use a drone to do inspections, because it's way safer and you can get to parts of the platform that you couldn't get to by foot, as it were. So here we have a drone someone operating the drone from the ground, flying it up to the. You'll see there's a telecoms tower, flying the drone around the telecoms tower. Rather than sending a poor guy up that tower, and checking what he can do, or checking what's up there, sending a drone up there. And what you can see, this is the resulting context capture mobile, the context capture resulting file. It's okay, you can get a good idea of what's up there, but it's not perfect. So here's the case study. So now, instead of sending the drone from the operator on the ground, get the engineer to program the flight path, basically. So the engineer programs the flight path, and this time, and you saw the concentric circles, program the flight path with the drone, look at the difference between what the engineer was able to program and get in terms of reality model. And he can really now assess and inspect that telecoms tower without having to go up there. So putting in the hands of the engineers the programming of the drone is now a state-of-the-art practice used by a number of telecoms companies, and this is like in the past 6 months or so. Basically gives you an idea. Another advancement now is what we call classifying reality meshes. So what you've got here is the reality model of a process plant. And you can see here, zooming in on this is a pump shape, basically. This is a fast evolving technology, and this is the demo I'm going to show you in a moment. Basically, the technology's got to the point now where you can highlight certain shapes, identify that pump with your asset database, link it to the P&IDs you've got, and the other asset information you've got, and you can see on the right-hand side of the screen there, the other information that's coming in from your maintenance management system or something like that. But linking your reality models with your asset information is a key thing that people are doing now, in order to capture what have your existing plants where you don't have a 3D model and not only capture the 3D model, but then start to identify what assets you've got on that 3D model through this kind of technology. And here, this was a prototype shown in December of we now can do capturing the photographs from a mobile phone, basically. So here you'll see, and I have this app on my phone too. It's almost released. It was supposed to be released a couple of weeks ago, but it's being released any day now. You take the photographs on your mobile phone. On the mobile phone, you submit the photographs. It goes up to the cloud, and then produces a result, which you can then you can then observe on your mobile phone here, and also send to the engineers. So now you've got the option of operators on the ground working out how can they may have an issue, they want the engineers' help in terms of how to solve a particular problem, and they can take a series of photographs using their mobile phone, get that process, share that data with their engineers, just like that, literally just like that. So this prototype was shown in December. We're now releasing this as a product 6 months later, basically. So it's all happening very, very quickly with this kind of technology. So as I mentioned before, we actually announced the availability of Context Capture Mobile at the SPA conference back in April, basically. And the beta versions have been available. We've been testing it. You can see here, this is a quote from Bureau Veritas, who are now very much using this technology to revolutionise their own inspection processes, basically. And I've underlined what I think is a really key sentence here in terms of reality modelling becoming pivotal in many industries and fundamentally changing the management of assets, reinventing the handling of inspections, maintenance and training, while opening up loads of new doors for new services. And Bureau Veritas, they're an inspection company primarily. They do certification and certification services, that sort of thing. But they're seeing being able to join up the guy in the site, the inspection guy in the site, with the engineer back at base, being able to then, when they see something wrong or something out of certification, that their inspector would just check off as being non-compliant, being able to engage their limited engineers in this problem and be able to then sell back to the organisation. In order to become certified, you might want to do, our engineer reckons this is what you need to do. That kind of value-added service is what they mean by adding a lot more, offering a lot more services, and again, transforming their business. So, Siemens, and this is where I'm going to start getting into the demo area. We've had a long time partnership with Siemens, and back in November they made a small investment in Bentley in order for us to quickly develop applications together. And basically we complement what they do with the digital models of the real world, basically. And then subsequent to that, back in January, after that, in January, we started working together with them and made an announcement about providing joint solutions for the utilities industry. And basically our expansion, our partnership, it started with digital factories and the automotive industry. It grew to the process industry. It's now with energy management, with transportation, with utilities and so on, and across the whole gamut of industries. Basically, we're working together. And you've seen a bit of this from the Siemens guy before, that we're very key to their strategic partnership, and particularly with MindSphere, and I'm going to demonstrate a MindSphere app in a moment, which we put together really, really quickly. So let me just get to that. So basically this is what we showed at Hanover Fair. We took an existing asset, i.e. this existing asset that they've got. This is their process automation world asset. They've got all the digital data for this, but they did not and could not get a reality model they had of that asset. Laser scanning didn't work and so on. So we created a context capture. We created we sent a guy with a camera. I'll show you the video of that in a moment. And then we went on beyond that to show very quickly how you could link your physical asset with the digital data that you've actually got. This is the technology that was used. Basically our context capture software, our AssetWise software, Siemens Comos database, their PLC, programmable logic controllers side of things, and then our AssetWise operational analytics. So let me show you, run this little video for a while, because this is, page up, sorry. I went over too quick. Yeah, it should, I have to play it, sorry. Basically, Siemens created this video showing the making of the reality model for this test. So here's my colleague Gernot. He basically took around 540 photographs of this asset, basically both far away and close up. You can sort of see the scale of this. This is a fully automated working plant that they use for testing their digitalization strategy. He then processed those photographs, and we created this reality model now. You can see there's 3 pumps down in the bottom, there's a separator, there's the 3 pumps, the separator, and so on. And then basically what the Comos team did was then take this model and bring it into their design environment. So basically this is a skid, and they kind of had a story around how would you reuse this skid in another environment. However, what we did with the same information was then build an application based on MindSphere. And this is what I'm actually going to now exit out of here and hopefully show you live. Basically, hopefully, she says showing you live. I'm going to the internet, and I'm hopefully logged in. cross fingers. This is basically bringing live data from various operational environments. You've got, if the internet was running quicker, you'd be able to. But I'm not going to try and move the model around, if you see what I mean. And it's kind of, sorry about you guys at the back watching this. But so I'll start again. We're basically on the internet here. This is pulling data live from the MindSphere environment. We basically ported our operational analytics toolkit to MindSphere, and we built this portal to demonstrate what could actually happen in literally 2 days. After we ported the operational analytics toolkit, our app, to run on MindSphere, it literally took a couple of days just to pull this together. So with little windows here, you've got the real-time data coming in. You've seen this, you've seen similar things like this from a couple of other presenters. You've got your real-time information coming in. This is the energy consumption and the flow rate from the 3 pumps plus the separator. You've got the reality model, so you can see the 3 pumps and the separator in context. You've got some information here from the some critical information here regarding the status of the assets, and you can see here that pump 1 is in a critical state. The pipe, it's a low flow rate. You've also got down here pump 1 is showing red in terms of and if I click on pump 1 here, she says confidently it's going round. You can see it's not previously done. Please hurry up and get to the so you can see it going around here. It was working quicker earlier. Hopefully I'm still on the fast network rather than the slow network. Okay. Mind you, it looks like it's a bit on the slow network. Oh no, there it is. There it is. Whew, that wasn't too bad. So it's focused, it's homed in on pump 1, and you can see you've got maximum electricity consumption and minimum flow rate, basically. And you can also see here in the window that it's highlighted pump 1. Do you see that? That's pump 1 there. So now you can sit from an overview point of view, you can see the pumping context and some of the issues. I'll go to the maintenance tab now, and it'll bring up the maintenance information quite quickly, I hope. 3 minutes left. So there we go. And it's again it should then have brought in this reality model, the window, so you can see the pumping context. You can see the historical information about the pump flow rate from the data historians that you've all got on your assets. And then in addition to that, if I pan down, you can see here the information from your reliability-centered maintenance environment in terms of what might have caused low flow rate on the pump. It's the bearings are worn, the impeller's gone, something like that. There's a number of reasons why there might be low flow rate for the pump. And then from this portal environment, literally you can now trigger maybe an action in SAP or something like that to trigger maintenance and get someone to go out and take a look at that pump. But from this portal environment, basically, you can see all of the data. So we put this demonstration together using a live environment. This is Siemens' own asset with all the data. We knew they had all the data about their pumps, etc., etc., etc. We created the reality model and used that that classification of the mesh. You can see the pump highlighted. In this particular case, we actually, they had a CAD model, so we were able to identify the asset by linking the CAD model to the reality mesh. But if I actually go and show you, you can see it better in detail here. This is the context. This is a fast viewer, basically. That's why I'm using it. But if I zoom in, this is the detail you get. One of the things that we're playing with now, I'm zooming in on this transmitter. Can you see everything come in? Still a 3D model, by the way. Okay, you can see that. As you can see, I'm zooming in. You can pick up all the labelling on the pipes. It says oil over here. You can see the tags here. But most interestingly for Siemens, is you see that QR code that's coming into view. We're going back to when we first captured all of the photography for the plant. We didn't really focus in on these labels very much. We don't have a terribly close in photographs of all of these labels. But now with the software, from the photographs, you can pick up all the QR codes and automatically start to identify the assets in your reality model. And I think virtually everybody now uses QR codes or barcodes or something like that. So all you need is the photography of those tags in this 3D model to be able to link the reality model of your existing assets with your operations systems, your maintenance systems, whatever it is, basically. So that gives you that overview. So if I go back down to here, and I go back up to I'll just go up here. I'll just, I don't go, basically. I'll just show you, sorry about the non-PowerPoint thing now. We ported our operational analytics application to the MindSphere and made it a Mind app. It was basically a web-based toolkit. A lot of the Siemens people are now using this to pull all of these things together. It wasn't a programmed environment. It's basically opening up the information you get from all of these sensors and what have you in that window. And hopefully I've basically proven there that it's actually fairly cost-effective, low-cost, very easy to actually add engineering technology to this Internet of Things. And we hope we've come up with good ways to actually, and we're constantly working on ways to automate this process and make it very, very cost-effective to integrate engineering information with your OT and IT stuff. With that, I'll finish.